And the next performance rockstar that will come on stage is the Stijn villain. That's Stijn Schepers. So briefly, I mean, he's been an expert. He's been speaking on various conferences, Eurostar, Whopper, PAG, Sigist, and other. He has built an awesome framework to analyze. He talked about it, so the robot analytic framework, RAF, that he talked several times. Now he is covering another dimension related to performance. It's the database. I mean, everyone is utilizing heavily Oracle. Oracle is the most well-known database engine. And sometimes you can have a lot of issues, especially when you're utilizing a lot your database. So Stijn's going to cover a bit more a song related to database performance. So Stijn, I let the stage for you. Let you rock on stage. Let you deliver your song.
Yeah, thanks, Henrik. Always good to sing some songs for you also this year. So now, always good to be here. It's the 7th time, I believe, speaking for Neotys back. It's a wonderful event. It's always good to share stuff. As a performance engineer, you do need to know quite a bit of stuff. Yeah, you have different layers or different topics. So it's good to know something about hardware, virtualization, software, configuration, going to microservices, your cloud architecture is also wonderful, network, database, knowing a bit of the business applications you're testing, data analytics. All those things are important for a performance engineer. And on top of that, we do need to do some stakeholder management. So it's good that we can talk to people. It's actually really important as a performance engineer and to become that rock star. And I think another thing that's very important is this continuous learning. The world is changing very quickly and we need to keep up with it. And my talk will be a little bit about database. And for me, that's really going a little bit out of my comfort zone. So I did a lot of continuous learning, studying the last few weeks about Oracle. And why did I do this? So I think that Henrik already mentioned our robotic analytical framework. So this is the latest dashboard. And very quickly, I'm not going into details. You can find some more information on the URL there. But basically, every day we do a peak load test in our production environment. And this is a bit of you. So with Neoload, we actually kick off a test in the morning. We do a peak load test live in the production system. And we export the results into a file structure, into a file folder. And then this robotic analytical framework is taking up the results. It's adding it to a central repository. And then it does some very smart analytics. And depending on the outcome of these analytics, what we call the test execution score, the test will fail, it will pass. And well, for me, when we look at performance testing an application, what's for me very important are the response times. That's really what matters. I call it the primary measurements. And then we have the secondary measurements. They are the resource utilization. But for me, they are a little bit less important because I rather have a user that has a good experience with a component that has CPU 100% than the other way around. So in this framework or within Neoload, we actually connect to Dexter, and Dexter is actually add-on or a utility from AppDynamics. On our environment, we have AppDynamics as an APM solution, and we have built in Dexter at the end of the test to extract all the information that we can, the secondary measurements from AppDynamics. And the good thing of doing this is that you will have the finest granularity stored on a file system. And my idea was there that if you discover any issues, you always can go back into that file structure on that specific day with that specific run ID to actually look at all the data that you've collected to maybe find more information about why performance is decreasing or why you have a system bottleneck. So back to that dashboard, what we see here is that the test execution score drops. We have the response times that are increasing. You see that also from the trend line. And you also see that at the right bottom, there you see a percentile graph. And I said in the previous talks as well, percentile graphs are awesome to actually see a difference in performance. From all the experience that we have with using this dashboard, whenever there is a slight difference in application performance, you will see the pattern changing in the percentile graph. So it's a very, very useful way of looking at your application performance. So yeah, the score drops, so we didn't meet the threshold. So of course we do have a problem. So there you go. How do we rock this problem away? This is a view from AppDynamics. So you see my application, and you see that we were doing some load to that Oracle database. And we did, what is it? Nearly 15,000 calls per minute, and the average response time was 2 milliseconds. Whoops, that's an increase from 1 to 2 milliseconds. It might not seem a lot, but it can make a difference. So the whole idea there was let's first look into the database. What's going on there? Why is it 2 milliseconds? And like I said, what's 1 millisecond? If you contact the DBA, he might say, oh, the performance is great. Every SQL query only takes 2 milliseconds. While you have your customer, your end user complaining about how poor the application of your web page or mobile app is. So aggregation does not do the trick. What I mean there, within Oracle, there is a lot of aggregation going on. And also, if you only look at the average, you will actually not see much. And I think that I promised Hendrik that in every talk that I do provide to him, that I will use the word raw data. And that's what I do now as well. We need to rock with the raw data. And we need to do that also with Oracle. You need to look at the finest granularity to actually detect performance issues, because otherwise they will be just faded away with aggregation. So what I did then, you remember I talked about Dexter and that we exported all the data. And we also have the APM installed on our Oracle database. And also there we exported a lot of stuff. And I thought, let's have a look in all the data that I've been collecting for over a year. And one of the files that I found was queries.csv, which I opened, and I did see this. I did see execution time, average execution time, wait, and a query hash, and actually the query as well. So primary measurements is about response time. So for me, this is important. I find some timings in this file. So what I did here, so I have for every morning that I do that test, I export the data. So actually I merged all those queries.csv files into one global file. So over here I call it the global results.txt file. And I used that one to feed into Tableau. Tableau, like Hendrik also said in the previous talk, is a business intelligence tool. We use it a lot. It's actually really, really good to look at your results. And what I saw there was this. And I was actually blown away. It was one of those moments that you think, this is really cool. So the question is, what do I see here? Lots of colors, and every color is it's related to a query hash. I mean, on Oracle, every specific SQL actually get a specific query hash, so it's a unique SQL query. And you see over time, the execution time is the horizontal, is the vertical line, is your y-axis. You see that on this system, on this application, we had 2 queries that are huge, and that we had a drop around 1st of December, and then suddenly, end of December, we see some orange you see some orange queries, and you see they're also quite big and they're new. And actually, when I look at, the other way around, when I look at the response time of the application, this is the response time. Here we measure web service calls, but it doesn't really matter. If you go back and you see this, I was actually surprised, because there is a real correlation between your application performance and your time spent in your database, your database performance. And at that time I put a video on LinkedIn and asking the community about how they see it, and for sure lots of performance loss, lots of time that you lose in your transactions, but actually time that you lose inside the database. So don't start blaming the database. Don't start blaming the DBA, because it's still an application that is using the DBA, and often it's the application using it in the wrong way, wrong queries, or even sometimes completely misusing, abusing Oracle. That happens as well. So I really like that, and it gave me some motivation to look into the problem more. So I'm going to take you a little bit on a journey about what we have been doing to try to detect this problem and maybe become a rockstar in Oracle. Knowing that I spent a lot of time looking at Java applications and the heap, and thinking that was difficult. It's if you compare it to the Oracle architecture, then looking at a heap is easy. So what we saw as well is, going back here, so you see all those colors, and then you see indeed those two different colors. They are new. Is this a new query hash? And this was a query hash that also existed before, but the time that was spent before was not even close to the one that happened at the end of December. I believe that if you do want to be a good performance engineer, you actually do need to know your systems. And that also means that you at least need a basic understanding of Oracle, if Oracle is your data tier. And so I started studying, and my question that I asked myself is, what actually happens when an application submits a SQL query? So I'm going to just focus on the read-only transactions, because otherwise I'm still talking tomorrow. So what I say here is, performance engineering is about getting to know the systems which you're testing. Only by understanding these systems you can efficiently test these systems. So what I did is I just started with the basics. And what is an Oracle database server? If you speak about Oracle, we also say the Oracle database. What is it? Actually, an Oracle database server, there are two components. It's an instance and a database. And the instance is your memory. It's fast. It's not permanent and expensive. And you have your storage, your disk, low, permanent, cheap. So instance, we speak about memory structures and processes. If we speak about storage, we speak about physical and logical storage structures. This is the most basic view of an Oracle database. So Oracle database, instance, database, two components. If you then go to the next slide, and it took me actually ages to actually compose that one, you get this view. And probably won't take a picture of it, because it's actually a very nice overview of an Oracle architecture. So the blue thing is the instance. What is it? Is it pink or orange or whatever? The other color is the database, but then you see everything within, or nearly everything within the Oracle architecture. So you see the system global area is the SGA, and the program global area, the PGA, and you may have heard about it, or when you were looking at Oracle resources or metrics, that you came across those, but actually didn't know what it was, like me before. But I'm not going to explain everything here, because that's probably also like 5 hours talk, but let's see what happens. So for a performance engineer, when you execute a SQL query, there will be an execution plan. And these are really important if you look at the performance of Oracle and your SQL query. And they are actually stored within the shared pool in the library cache in a shared SQL area. Important for a performance engineer. A SQL query will be parsed by what they call the optimizer. It's an extra piece of software on an Oracle database server. And this optimizer is using the optimizer statistics, and they are stored in what they call the data dictionary cache of the shared pool. And you also have the Oracle performance views, and I will be talking about that quite a bit later. They are also stored here in the data dictionary cache. And then we have data blocks that are stored in the data buffer cache, also extremely important for a performance engineer. Because if you don't need to go to your physical memory, it is faster to fetch the data back to the user or to the client application. So we speak about logical reads as it comes from the data buffer cache, physical reads, physical I/O when you physically have to go to your physical storage. So what happens when a client application wants to connect to the database? So a user or an application starts a user process. The application attempts to establish a connection to the database. We have the listener that is actually listening for that connection, and will actually make that connection happen with the database. Then our application is running a SQL query. Select store from songs where artist is Bob Dylan. I wanted to add and song is less than 10 minutes because sometimes it goes on and on with Bob Dylan. Anyway, select store from songs where artist is Bob Dylan. Then what happens? Basically, the server process is going to look into the share pool if that specific query if there is already an execution plan. If that's not the case, the optimizer needs to do the work again and create that execution plan. We call that hard or a soft parse. Performance is better, of course, to have a soft parse. Then it will look into the data buffer cache, or is the data already there, or do I need to go all the way to the physical storage to retrieve the data and fetch it back to the client? Very, 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 very basic. User makes connection, session is created. The parsing, so that's the operation of converting SQL text to an executable version. Parsing involves allocation of memory, validation of the SQL statement, and the creation of an execution plan. It doesn't include the execution and the fetching, but there are two ways of parsing, like I previously mentioned. We have the soft parse, which does a syntax check, a semantic check, and a shared pool check. Shared pool to see if the query hash or the specific query is in memory. If that's the case, we call that a cache hit, and we do the execution and the fetching. Otherwise, it will be hard parse, meaning the optimizer needs to actually generate that execution plan, which consumes quite a bit of CPU and is slower, and then it fetches back to your application. Oof, this is already complex, and don't worry, I have a lot of information. I call that my extra songs or my bonus tracks where you find the basics about the Oracle architecture. So you can have a look to that later. So I talked about primary measurements, response time matters the most, secondary measurements, resource utilization. So if you look at Oracle, and if you look at that SQL query where we want to retrieve the songs made by Bob Dylan, we talk about SQL elapsed time, and SQL elapsed time is nothing more than the CPU time there where your process is actually doing stuff, and the wait time, and there can be different types of wait time, different reasons why we are waiting. Also, we talk about database time, and database time is actually the sum of SQL elapsed time in a given time period. There's also the sum of your wait time and your sum of the CPU time. An example here is an extraction from AppDynamics. We did 1.88 million SQL transactions, SQL queries in the last 1 hour, and the database time is here 5 hours, 30 minutes, 25 seconds. So it's really the sum of all the elapsed time of all those queries, which we call the database time. So looking primary measurements, performance times in Oracle. So here's my Oracle server, SQL elapsed time. Here's my application. It's a virtual machine with my JVM and my heap on a ESX cluster. It's application response time. And then we might have a web front end where we submit that query, and we call that the end user response time. It's still quite an easy flow because you probably have a front end tier and an application tier, but just to give you an idea about where it all fits. So I talked about the performance views of Oracle, and I had a look to those, and you can query those yourself. And here you see two examples of what we call performance views. It's the one that is called SQL Stats. The other one is called event name. With the event name, you see the different weight classes. So you see there are quite a few reasons why your query can be waiting. But in the SQL Stats performance view, you see a lot of useful information. You see CPU time, you see buffer gets, elapsed time, user IO wait time. So I thought, this can be very useful. The performance views, they're also used by your DBA looking at your AWR reports. They are using also those performance views of Oracle. And there are hundreds of performance views, so I just showed you two. The $SQL area lists statistics on shared SQL area. So that's your SGA shared pool. Remember that the beautiful picture I showed you, and contains one row per SQL string. It provides statistics on SQL statements that are in memory, parsed, and ready for execution. Important, it's an aggregated view. So if you reboot your system, it will be empty again, and you will extend it if you have more load on the system. And for me, this was my light bulb moment. And why do I say that? I said, but if I can actually query that view, and you need specific rights to do that, by the way, but if I can query that, I can include this as well in my automated framework, the framework that we use to do daily testing, 7 o'clock in the morning. Why do I not call that specific view to actually extract response times from Oracle? So I had a little bit of a play with Oracle and with my load test tool. So we used Neoload, and what I did, I created an additional user part or a script in other tools. What I do here is actually simple. I do connect to the Oracle database of the system under test. I check that that connection is set up well. Then I create with the JavaScript the select statement to actually call the $SQL area view and retrieve the information. So with the JavaScript, we actually compose the query, and then within Neoload you have that SQL statement where you actually commit that SQL query. The nice thing with Neoload here is that you can actually extract the return from your SQL query, the response from your SQL query in variables. And other tools you might call that correlation, and Neoload is called extractors. So here I extracted the returned response into variables called application wait time, cluster wait time, discrete. So all that useful information from that query I actually collected. Then I disconnect. I connect to my robotic analytical framework result database, the MySQL database. I create this insert statement, and I insert those metrics as well inside that central repository. So I not only have the response times and the analytical metrics from my robotic analytical framework, I also have that very useful information from Oracle inside my database, which is also stored under the same run ID. I disconnect. So, of course, to be able to do that and insert it inside the MySQL repository, I needed to create a new table, which I called Oracle Metrics. So when I execute a test, I first do my business transactions, half hour of load test. I extract the Dexter metrics, and then I call the Oracle get metrics script that I just showed to you. And you see, I gather all that information inside my result database. And of course, there you have it again, my Tableau BI tool, which I also connect to that data. Yeah, let's try that. Demos always fail, so always a little bit afraid of it, but let's go here. So this is some data from my test environment. I did a few runs. You see, I was quite pushing it because I was still working on this the 22nd of March. So thanks, Hendrik. A lot of work to get this done. Anyway, here you see some executions. And you see the test execution score, and then all those beautiful dots. That's what I call the raw data, the response time from every run. You see a trend line, and you see that percentile graph which I showed you before. You see different colors in your test execution score. Orange means that there is a warning or a review status. What I did there, I actually increased the amount of load in run ID 9 and 10. I did that on purpose. And what the robotic analytical framework is doing is comparing the response times with the baseline, but it's also comparing that your load is similar as your previous run or nearly similar. And of course, if that's not the case, provides a warning or a review to say, hey, there's something going on which is not linked to your response times. And then you see the red ones, and they are the failed ones because the response is way too high. You see that as well in the percentile graph. And you see that in the average response time. So what I did then, so I have put all that beautiful data from the SQL, from the Oracle Performance View inside the database. And so I go here. So this is another view. So this is here you see some of the information that I did get from Oracle: buffer gets, fetches, execution time, CPU time, total wait time. And going back to this one, we see that the two last runs where the performance was really bad. And what we see here straight away, because I collected it, if you go here, there are colors, all different colors, different transactions. You see different run IDs. Orange, what I said was failed, was executions that were under review. The red ones are the failed ones because the response time is high up. So if I go now to the collected information that I got from Oracle, I do, you get this view. Call that the SQL area info. And from you see run ID 1516, indeed, that if you look at the execution time, that the execution time of 3 queries is, or 4 queries is way higher than before. You can then also see which specific SQL ID is behind this, and the SQL ID you can also retrieve the SQL, so it provides you insights. And okay, I measure performance that is not so good, and then you get that extra information from Oracle, which then already explains you to which queries you do need to look at. And then I created what I called the detector. The SQL detector. I should have called it something with rock stars, but anyway. So I love this. I should present this for a painting exhibition. But here you see different metrics that are linked to different to SQL queries. What you can do here, as an example, I can just go over here and I can walk through all those queries and look at them and see, okay, what are the specifics to that specific SQL ID. So it provides you with a lot of cool information. Or you can also say that you're interested by one specific one. You can look for it. Here I'm looking at this is an aggregation of all the run IDs, but of course you can say, okay, those 2 last ones were really bad, so I'm going to get rid of those, and then you see a different view, and you can, if you want, you can compare those. I think this is really, really cool because it provides you really bit more information. And then this one is actually This is the last two run IDs. It's a dashboard that has combined the Oracle elapsed time together with the metrics that you saw before. So for me, composing this, because this was a little bit of an experiment just for this presentation, to be honest, but we will keep this for sure inside our framework because it will provide me with so much more information straight away from Oracle that you already go to your system bottleneck, which were specific queries. So that's the query hash execution time. Yeah, going back to the problem that we had from the previous slide, very quickly, what happened there? We see some new queries, query hashes, lots of CPU using, lots of execution time. It's the optimizer. It's the optimizer that is actually creating the execution plans. It uses actually the statistics, and it creates multiple plans, compares them, and the one with the lowest cost will be used as an execution plan. But sometimes for complex SQL queries, there are actually millions of action paths. The Oracle optimizer is limited to 2000 guesses. Oracle can change the execution plan on the fly. So while it can actually what this actually means is that you can do a test and your performance is okay. You do the same test again, performance will be different because Oracle did some automatically change the execution plan. So impacted the performance positively, no difference, or a huge negative impact. This is a really good YouTube video. It opened my eyes because it actually explains how complex Oracle is and that there are things happening that you even can't imagine. You do the same test, performance will be different. What's happening? Oracle decides to do it slightly different. But actually, the good thing is that you can influence the optimizer, and that's what you're looking at. We are going to actually introduce SQL plan management, and then instead Oracle doing it on the fly, it will still generate that new execution plan, but then it's still up to the Oracle DBA to decide if that one is more efficient or less efficient, looking at performance. But let's conclude with this, with my last 6 slides. It's going to be quickly, we're nearly there, and I hope that I can get some feedback about this. So rock stars, they play live gigs. What do I mean with this? Production is the only production-like environment. And I think that we should, as performance engineers, use it and use it wisely for performance and load testing. Remember Oracle deciding things on the fly. It's changing all the time because you have always load on the system. So Oracle gets that load. Optimizer will change execution plans. It's not happening in your test environment. So if you really want to look into how your application behaves, like what we do is daily testing in production. So you get that beautiful image of your application performance on a daily basis in production. But you need to understand your application. You need to become that rock star to be able to do it and not impact your production users. Rock stars don't play with broken equipment. What we saw as well, there was another problem that we saw that was actually linked to an old framework that we introduced on Oracle, which was PSQL, and it was very small when the developer actually wrote it, but then he left and it grew, and no one really knows it anymore. And that's a beautiful example. It's actually here it is nearly not using where Oracle is designed for, and it's a typical example that you might recognize. Someone long time ago has done something, but he is gone, so no one actually wants to touch it anymore. And that's about technical debt. And technical debt is a killer, specifically in DevOps, and we need to decrease the technical debt and avoid creating new technical debt. And I think it's really important, and I still see also with Agile and DevOps that the main drive is on functionality. You have those DevOps teams with a backlog, and it's nearly always focused on delivering as much features, functional features into production. There needs to be technical features as well. Your definition of done needs to have some non-functional aspects in them. Rock stars practice a lot and want to do better every time. A performance engineer must learn continuously. Every iteration they need to improve how and what they do. Good example is what I just described, we saw we had a performance problem, and we, as a performance engineer, we looked into ways to improve the way we were doing by actually calling that view and retrieving the information and getting more insights inside Oracle. Rockstars love smashing guitars and buying new ones. That's right. Not sure if Bob Dylan did that. Anyway, innovation requires budget and time. This needs to be included in the way organizations operate. Again, also linked to the technical debt. I think when we want to do innovation, when we want to create new frameworks, there needs to be time allocated to it. And at the long run, it pays off itself, but there needs to be investment on. Let a rockstar be a rockstar, also on a DevOps stage. I think that I touched that as well on the Whopper when I spoke about the T profile. You've heard about the T profile or the generalists. What I say here is specialists need to continuously specialize. Not every discipline fits in a DevOps team. So an Oracle DBA, I do see him as a specialist. And sometimes things are being allocated to DevOps teams and they really don't have the knowledge and they don't have the time to build up that knowledge. And I don't think that's a good way. Really, a specialist should focus on what he's good in and not become that generalist and really lose touch with the technical aspects of his expertise. Rockstars don't play songs on request. Maybe they do, but the good ones don't. A ServiceNow system for ad hoc random requests for the shared services team does not work. What I mean here is that you could have a team of Oracle DBAs that are part of a shared services team, and DevOps teams from different value streams. They might create ServiceNow requests, and they are being sent to that DBA team, and they take that up ad hoc. And they're really busy doing this, so adding a user, changing the scheme, but they really don't have the time to look into the real stuff, into the architecture, into improving Oracle. And I believe that the DBA should continuously look at the performance of Oracle and continuously in the context from that application. And if you just take up ad hoc requests, you actually don't build up that expertise that I talked about previously as well. And don't be a one-hit wonder. Learn, make mistakes, make a lot of mistakes. Don't stress, enjoy the journey. We can be heroes, not just for one day. So I actually open the stage for any questions, and feel free to connect to LinkedIn, send me questions there. Always happy to provide answers if I know them.
Thank you, Stijn.
You're welcome.
So we have a couple of, I'm looking at the time, so it's less, we're supposed to have a small. So I'll take a few questions. So there are, in fact, a couple of questions that has been pushed by the attendees. So I'm going to ask a few of them. Just briefly, I know that you already answered briefly that question, but maybe you could remind to the community, is Dexter an out-of-the-box feature from AppDynamics? If not, where can they find Dexter?
Very easy. Google and download it. It's not too easy to use, but there is a lot of information on it. And if you have problems, connect to LinkedIn and we can help. But also AppDynamics provides awesome support there. So yes, it's well maintained, and I had a chat with the guys from AppDynamics, and they are still maintaining it. The guy that actually wrote it, he left AppDynamics, but it's still maintained, and they don't have any. They're not going to remove it.
Also, one thing that I just want to mention for all the attendees, because there was a question about, you said rock stars do only live gigs, but rock stars, before they go to the live gigs, they practice a bit to make sure that the live show will be good. So just to add, don't start in testing in production. Practice a bit before. Know your riff, know your song, know your chorus, know the rhythm that you're going to set Otherwise, it's going to be a disaster.
That's for sure. But it doesn't mean that we shouldn't be testing. I like to actually talk about that a lot because some people are, oh, what is he talking about? And is he completely insane? I think that testing is about taking risk, but knowing how big those risks are and understanding what the benefits are. And of course, we did a scalability project around this application, and I know it inside out, and that's what you really need to know if you test in production, because otherwise, yeah, you do take big risk, but that doesn't mean that you shouldn't be doing it. Build up, become that rock star, and then see in how you can be doing it, and do it carefully.
So there's a question from Roman from the attendees. So if the engineers are focusing too less on the NFR SLOs, would you suggest to open technical depth in case they introduce a function resulting in a slower response time?
That's an interesting one. That's a very complex one because it's something that it's also the move to the DevOps teams with performance engineering as a service, trying to actually let the DevOps teams do a bit what we used to do, and having slow performance. I think it's with if you look at the SLOs and Google, they speak about an error budget and delivering features. It's a balance between actually building up technical depth and delivering features. But I really think that the focus is too much on delivering functionality, and at the end it will bite us. But it's different. You're not going to hold the feature. You're not going not to deploy a feature when the response should be 1.5 seconds and it's 1.6 seconds. So it's always a balance. But I think that the balance now the balance is not okay for the moment. That's what I feel. I still feel that performance is secondary, also in Agile, also in DevOps, even with all the SLOs in the world, because they are not easy to define. It hasn't become easier.
And are the SQL statements that became slower, are they directly linked to requests that happen in the application, or is it something that is completely like running in parallel batch stuff, or is it directly, for instance, linked to your load test? It is, right?
Yeah, these were, and that's the complexity of Oracle. Oracle is the biggest monolith on earth sometimes, because it does sometimes get a lot of information, or you have batch STP online, different, it all comes together, and I get sometimes nervous that the DBA doesn't want to understand the applications sometimes. Well, you really need to understand the applications to be a good DBA for that in the context of that application. And otherwise it will be just an aggregation of lots of queries, and then it becomes difficult to actually know what's happening. But these ones, because I actually do that early morning, there's nearly no traffic. I always do the same test. And at the end, I extract the data from the half hour that just passed with Dexter. And that's actually really cool, because then I have it from the context of my application. Because even batch is not running then. But you're right, you need to be careful because AppDynamics will also not know, I believe, if it's just from batch or not, but these ones are definitely linked to that application. And that's why you also saw beautifully the correlation between database time and your application performance.
All right. So to get to my question, this was more like a before I need it. No worries, no worries. So I was actually curious because from APM tools, you should be able to get out the information as well. That I'm not an expert in AppDynamics at all, but I am in Dynatrace, and I know and it works pretty similar. So we have there these top database statements view, and I was just curious that maybe you could, additionally to what you do, also fill out this data in AppDynamics. Have you tried, and did you reach some limitations there where you had to like deep dive into Oracle to get, of course you won't ever get out of the Dynamics this level and granularity that you have of the data, but at least for, let's say, different queries and how fast they were, I thought it should be possible. Have you checked on that, and was it not possible? Or?
No, very good question. I need to be I need to thank Henrik because I wanted to do something special for this one. When he said, okay, I want to do a different talk and don't talk about raw data, and we were having just a problem with Oracle. And I said, okay, I'm going to talk about Oracle. And I've been sweating. I've been like, oh God, I need to do something special. So it was also an experiment to see, okay, how from a test, if you don't have an APM tool, how can I retrieve that data?
Yeah, exactly. Because if you don't have...
And also, what I see also with DevOps now, I hope, Arthur, you're going to touch it, the operational monitoring. Where does it belong? Who's responsible? Who's going to do it now? Or the DevOps teams? Who is it? So you can have the most beautiful Dynatrace dashboards. If no one is looking at them, they don't have any meaning. And I find there's also a problem with the move to what we are doing now. Everyone is responsible a little bit. But still, clear responsibility in agile world about operational monitoring. I want an answer, Arthur.
But that's sort of tips as well.
Was the reason that the same query took longer after than it was before? Was it the plan executor which changed a different execution plan, or did you figure out what was the reason why the same query took longer?
So in the one from my test environment where you saw the two red execution IDs, we discovered actually a different problem with the REC database. So we have a cluster. So we have two instances, and we have a PSQL framework basically that is creating some big objects that are not being synchronized and creating a waiting event. So that was the reason why. So we are still with Oracle to look into how to solve it, because we haven't really solved it yet, because we do want to run on two REC nodes, of course.
Yeah.
And the other problem with production was actually really the optimizers changing the execution plan. And we are really going to look into SQL plan management to actually avoid this to happen automatically and it's quite easy because we have 4 or 5 queries that have the most impact on the database. So we're going to do that a little bit smarter to avoid this to happen. And specifically, if you upgrade Oracle, you need to be careful with all the new features, what I said in my introduction. Be extremely careful with all the automatic features. We have automatic correlation and load test tools. I never use it because I want to do it myself. When you know how to do it yourself, you can actually see if the automatic stuff also works for your application, also within Oracle. Because if Oracle does something for me, I actually want to know what it does for me. And then I can trust it and I can apply it, but be careful if you upgrade.
Yeah, that's so tricky. Like if you don't know that Oracle can change the execution plan at any time, and you're like, what happens now?
And it might never happen, and then suddenly it happens, and then you have the normal discussions. Oh, we didn't do a release. Oh, we did. You know the stuff, and then it starts becoming tricky. So having as much insight as possible, that's the key to a quick resolution. And then monitoring indeed your top 10 queries all the time. And if something changes, you really need to understand what changes.
Thanks, Stijn Dillon, not Stijn Schepers, but Stijn Dillon, for its awesome presentation. That was great. And also thank you because you also dressed like a rock star as well. You're the first speaker who did that. So this is great. Awesome. Stijn, you was there. We can count on you. That's great.
Thank you for actually organizing this again, because this is wonderful, having a platform where you have like 65 people specialized in performance, listening and contributing. I think also that deserves applause. Thank you.